Alrighty, so our next lesson is we're going to work on solving systems of equations using algebra. So we've already done systems of equations by graphing it and seeing where the two lines meet. Now we're going to do this using algebra. So let's get an example on the board up here. We're going to start with this one. It's 8x minus 3y equals -1. Okay, and x plus 2y equals -12. All right, so we could, if we wanted to, convert both of these equations to y equals format, and we could graph it on a graph, and we could see where the lines intersect. If they didn't intersect, we would say no solution if they were parallel. If they are on the same line, we would say infinite solutions. They share the same line. And if they crossed, we would have one solution and we'd be able to say that XY point. Okay, but we're not going to do that this time. We're going to do it using algebra. Some of you are going to like this method, some of you aren't, but we're going to all practice it. And then towards the end of this unit, you can choose which method you prefer. Okay, so first, the way that I like to do this is I want to solve one of these equations to be for one variable. Okay, so either a y equals or an x equals something. And so I like to stop and think for a minute. There's not an obvious one to do or like a formula to use. You have to sort of stop and think. Which one of these two formulas, which one of these two equations is going to be easiest to get just one variable on one side? So in this particular case, I was about to write on my screen, that's not helpful. I'm going to choose this equation because I already have this x that's not multiplied by anything. I can simply subtract the 2y from both sides, and I have x equals -2y minus 12. Okay, so this is my first equation. Okay, we still have that. This was my second equation, but I've converted it to this format where it has just one variable on one side of the equation. Okay, now what we're going to do next is we're going to do what's called substitution method. Okay, and so this substitution method, I'm going to take everything that this x equals right here. So I'm going to take this expression, -2y minus 12. And since that's equal to x, I can substitute it in for x up here. So let me show you what that looks like. I'm going to put it over on this side of my screen. Okay, and I'm going to write this. So I'm going to start with 8. And here, instead of writing this x, I'm going to write -2y minus 12. Okay, now I'm going to finish writing my equation. So I have the -3y equals -1. Okay, so this equation, right here, is exactly the same as this, except that the x has been substituted with this. All right, so now I'm going to distribute and solve this equation for y just like I would normally do. So 8 times -2y is -16y. 8 times -12, I'm going to have to use my calculator for that. You might know it off the top of your head or have some clever way to do it. I'm not going to do that. -96 minus 3y equals -1. I'm going to combine my like terms here, the things that have the y. -16y minus 3y is -19y. I still have that -96 equals -1. Okay, now I'm going to add 96 to both sides. Here I have 95 equals -19y. Going to divide by -19. I sure hope this comes out nicely because that's our goal, isn't it? Oh, it did. Okay, so y equals -5. Okay. Now, we still have to find x. right? Because when you solve a system of equations, we're looking for an XY point where these equations meet, right? Where the lines meet. We only have the y equals -5, so we are not finished yet. What we're going to do is we're going to take this y equals -5. We're going to substitute the -5 in for this y. That's going to tell us what the x is. So here we go. We have x equals -2 times y, which is now -5. We're substituting minus 12. Okay, so -2 times -5, that's +10, minus 12 is -2. I'm going to erase that and make it slightly prettier. I made that little weird thing. So x equals -2. Now, if I were to write this as a point, I would write it like this: -2, comma, -5. All right. So this is what we would call solve a system of equations with algebra, or with substitution. Let's call it substitution. Okay, so that's one example. I am going to erase this example and do another example for you to check. Make sure that you're feeling comfortable with this. So if you need any of this other information up here that's on the board, definitely make sure to pause that, rewind, go back, get that example written down fully for yourself, okay? So here's the next example, solving a system of equation with substitution. We're going to get this equation written down: -5x plus y equals -3. Our next equation is 3x minus 8y equals 24. Okay, so our first step here is we're thinking which letter is easiest to get by itself. Okay, which letter is the easiest to get by itself? And in my opinion, this y is easiest to get by itself because we can just add the 5x to both sides and we'll have y equals, so let's write that down here. So I'm going to put a little arrow. Okay, so we're going to add 5x to both sides. So we have y equals 5x minus 3. Okay, and this y, now that we've got that, it can be substituted into this equation for this y. So let's go ahead and do that. I'm going to put it out here to the side like I did last time. 3x minus 8 times, instead of y, we write the 5x minus 3 equals 24. So let's go ahead and distribute that -8. So -8 times 5x is -40x. Minus 8 times minus 3 is plus 24. Okay. So here we go. Let's subtract the 24 from both sides. And actually, I could do this too. 3x minus, well, let's do it one step at a time for the video. Okay, 3x minus 40x is -37x equals 0. That means x has to be 0. Anything times 0, or anything that equals 0, if it's multiplied, it has to be 0. So x equals 0, that's our first step. And so now we're going to substitute one more time. We're going to take this 0. We're going to plug that into this x. Okay, so we have y equals 5 times 0 minus 3. So this is 0 minus 3, which means y must equal -3. So we have an xy pair, 0, comma, -3. So now we've done 2 examples. You're going to try some on your own. So again, this is solving systems with substitution.